Buenas tardes, gracias por acercarse al Salón Miliano. Gracias también a los que están conectados de manera virtual. Hoy vamos a comenzar, es la primera charla del ciclo de seminarios que organiza la Facultad. Y en esta oportunidad nos visita Romualdo da Silva. Bueno, Romualdo se graduó en física en el campus Pesqueira del Instituto Federal de Pernambuco. Obtuvo una maestría en astronomía en el Observatorio Nacional de Brasil, enfocándose en el estudio de variables cataclísmicas mediante observaciones en rayos X. Actualmente es doctorando en astronomía en la misma institución, dedicado a la búsqueda de nuevas variables cataclísmicas, utilizando datos de reglamentos fotométricos SPLAS. Además, realiza un doctorado en modalidad sándwich en la Universidad Nacional de La Plata, donde investiga la detección sistemática de estas variables mediante técnicas de aprendizaje automático. El título de su charla de hoy es Nuevas estrellas variables cataclísmicas identificadas a partir de datos SPLAS. Bienvenido.
Gracias. It's my pleasure. So, my name is Romualdo, and I am a student from Observatory Nacional. I'm open to doing an internship PhD with UNLP, and this presentation is about new cataclysmic variables stars found in the okay. So, cataclysmic variables are binary systems, compact binary systems, with orbital periods between 1.3 and 3 hours. And these systems are formed by white dwarf, how the perimeter of the system, and has a low mass of the secondary of the system. Okay, so this secondary transferred mass for white dwarf. This transfer that height mass about this value solar mass per year, and because the accretion onto surface the white dwarf produce X-ray radiation, and this luminosity in X-ray isn't function the gravitational potential of the white dwarf and the rate of accretion onto the white dwarf. The typical value for luminosity in X-ray is this value here, okay? For the systems more brilliant in X-ray. So this transfer of mass for the white dwarf can form a disk accretion or no around the white dwarf. This form or no of the disk depend of the intensity of the white dwarf magnetic field. And about magnetic field is very useful for classify Cataclysmic Variables Stars and its types. Okay, we have 3 cases here for intensity the magnetic field. So systems with white dwarf magnetic field very strong. The material of the secondary is the magnetic field lines, the white dwarf control the material, and this material not forming in disk around the white dwarf, because the material is form columns accretion, and the accretion is through the magnetic poles of the white dwarf, okay, and not through the disk. In this case, we have 2. So the systems is called polars. So polar systems with magnetic field very strong. In the case we have magnetic field moderated, the material form a disk, but this disk is truncated in the inner region because they action the magnetic field lines of the white dwarf. These systems are called intermediate polars. And for no magnetic systems, the material form a disk, and this disk extends nearby the white dwarf surface. Okay, so about the columnar accretion, here we have a zoom in on columnar accretion. Okay, so the accretion material experiences shock a high H from the white dwarf surface. This rises the plasma. So the plasma has a temperature max. In the post-shock region, the material at approach the surface of the white dwarf, the material cools in direction the white dwarf surface. So because the material, the plasma increase your density, and this density increase the emission for brainstorm, and the material increase the temperature. So this phenomenon is called cooling flow. Okay. In a magnetic system, the cooling flow exists too, and this is present in a region between the disk accretion and the white dwarf surface. So the shock the temperature is depend only in first order the magnet the potential gravitational of the white dwarf. Here I will speak about the signature for fine cataclysmic variable star. So the cataclysmic variable stars are very variable systems. Okay, so this variability in optical can be periodic when associate the orbital period or the rotation of the white dwarf, and can be stochastic when associated with accretion disk stability, how the outbursts and explosion on the white dwarf surface. And the other signature is X-ray emission, because they mass exchange between the components. Okay, so these two signatures have been used by surveys in optical and X-ray for found cataclysmic variable star. But we have some problems with this. The first problems is the optical via optical variability favor objects with detectable recurrence and amplitude, and X-ray favor systems whose emission exceeds detector sensitivity and detected nearby system, I don't know, 1.5 kiloparsec. So in this we have a selection bias of the different types cataclysmic variable star. For example, the polar systems that are systems magnetic represent 1% of the total population of CV. Others type the cataclysmic variable is the CV spirit pulsars. CV spirit pulsars are CVs with low accretion rate, and we know just 14 systems confirmed today. Other systems are the intermediate, low luminosity intermediate polars, are systems with low luminosity X-ray and very hard detected by survey in X-ray. We know just only 13, I don't know, 13 systems. And for example, other systems are the systems in period gap. The systems in period gap This is a figure of the orbital period, the distribution in orbital period of the cataclysmic variable stars. See, here between 2 and 3 hours, we have a few systems observed, because in this region, in this phase, the cataclysmic variable stop the transfer mass, and these systems has low luminosities or few brilliant, and don't has emission in X-ray. So this leads to an underestimation of the true service population and an incomplete understanding of the evolution and physical properties of cataclysmic variable stars. So my research group have used the Southern Photometric local universe survey for Facultad variable. That use methodology. This new methodology is different than previous surveys for Facultad variable, because not depend the variability or X-ray emission. So the S plus is a survey, photometric survey with 12 filters, 5 broadbands and 7 narrowband filters. And the methodology is how I say, not depend the variability, okay? Here we have a spectrum of the cataclysmic variable. We see the continual emission because the presence of the white dwarf, and the emission in emission line emission because the material in accretion. Okay. Here we have a spectral CD and spectral energy distribution of the S plus with 12 points, and we can see here the presence of the white dwarf in the material in accretion through the excess in blue region, because the presence of the white dwarf in the line emission. Okay, so this excess increase in direction the wavelength, but this trend is broken because the presence of the secondary star in the line emissions. The secondary stars and the disk of accretion has a contribution for the red in this region, in the red the spectrum magnetic. Okay, so this form the V shape. We see the 2 components, more material in accretion and to the H alpha emission because the material in accretion. Okay. This is suited in the pilot project. In the pilot project, we found 10 new cataclysmic variable stars, and these systems was confirmed by spectroscopy with the Gemini. And this work used the data release trace for the S plus. And now in my PhD thesis, I use the data release 5 for applied technical and cataclysmic variable and study the systems. Okay, so we begin by selection H alpha emission through the comparison of the H alpha band with the R and I bands through the expression here. So we have the H alpha catalog for work for our work. Before this, we constructed a model based of the series of the Cataclysmic variables known in the literature to search the object in S plus whose the sets displayed on the shape. This resulted in 161 sources. Here are the series, the objects confirmed in the literature. All display the excess in blue, excess in red region, more plus the H alpha emission. And here we have 109 targets that are our candidates series. So we request time for the Gemini, for spectrum, Gemini-South, and we confirmed 16 new circuits through the spectrum. Here we have some the values, the values of the G-band Gaia for the saucer and the X-ray luminosities with Zeta. So all these systems display seven systems display low luminosity in X-ray. So these systems can be intermediate polars, hard systems. Here are the series of the 16 systems. And here is a rate-to-rate diagram using the S plus band. And all the systems, all the system selection are within this box here. Okay. So here we have an HR diagram and the X-ray asynchronous diagram, and here we have all the select systems through the V-shape method. So you can see these systems are localized between the white dwarf regions and the asynchronous region in this diagram. So it's because the cataclysmic variables are formed by white dwarf and they unstar the asynchronous. Okay, so this is our localized between two regions. This is indicate other filters for select cataclysmic variables. On the other hand, in X-ray asynchronous diagram, we have a ratio between the flux in X-ray and optical, okay, versus color of the Gaia. And all the systems are localized above the line that separate X-ray emitter objects by accretion from those that emission X-ray due to coronal activity. Okay, so all the systems can be systems cataclysmic variable, and of the candidates can be cataclysmic variables. The probability is high. Okay. Here we have the spectrums, the 13 systems. The other three systems that we confirmed as polar will be published in another paper by the Araújo et al. And here we have the systems, this work, okay, this spectrum. All systems display the emission lines and H alpha, H beta, for example. The three magnet systems are three polars. These polars, because they indicate the emission line in area 2. So this line is because the plasma component magnet polars. So in this case, the plasma reach high temperatures or they produce this line. So the comparison between this line with H beta is indicative the magnetic systems. So we have three systems in this condition. The other 6 systems can be intermediate polars because the presence of the N2, but the comparison with H beta is not so strong. Okay? So this system can be intermediate polars because the intensity magnetic field is moderate. This system has two low luminosity in X-ray, so can be intermediate, low luminosity intermediate polar. The other 7 systems are no magnetic CVs because they no presence of the N2. We research for line curves for the systems in archival data with the ASIS-SM in tests. We found line curve for 7 sources in ASIS and for 1 source in tests. In the case of the ASIS, some sources are outliers with explain the main unidentified CVs in private surveys because we see the outburst here and outburst here in just 2 sources. For tests, we found line curve for 1 source, and here we have the line curve in test. This line curve displays an outburst. This outburst, if with amplitude 1.06 magnitude and with duration 4.3 days. In this case, we apply the Lomscargo paragraph and we find in period 2.3 hours. When we folded this line curve, we see the eclipsing systems. For example, here in the decline phase. So this is interpretation is how the orbital period of the systems and is in her systems because is in period gap. Okay. We have got some time observation for photometry with SPAC 4. The SPAC 4 is an instrument that makes simultaneous observation in 4 bands. This instrument is mounted on the 1.6 meter telescope in the Observatory Pico dos Dias in Brazil. Here we have a line curve for one day new polarity that we found. We find GREZ during 2 nights, and this line curve display variation that we interpret as being consistent with the emission for the white dwarf poles. And in polar systems, the magnetic field line, the white dwarf, are coupled with the magnetic field line, the donor star. So in this case, the orbital period of the white dwarf is equal to the orbital period. No, the orbital period rotation, the white dwarf, is the same of the orbital period of the systems. In this case, we have a period 3.5 hours. So we have a new port above the period gap. Here we have a light curve for other source in 4 bands. So we see eclipses of the secondary that more pronunciation in the I and Z bands, for example, here. And the period of the system is 4.2 hours, and this is a new CV above the period gap. About the X-ray analysis, we found observation in X-ray for the system for the new CVs, and we reduction of the data, and here we have 3 spectrum in X-ray for three instruments, the X and U2. Okay. This line is the fitting with the conical model. So the conical model, the parameters are the max temperature and the rate accretion. So we determine the temperature in rate accretion of the white dwarf and X-ray luminosity, for example, and we use the relation radial mass for the white dwarf and the expression for max temperature for the plasma. We have a relation between temperature, max temperature, and mass. And mass was the white dwarf. So we use this value found through the model. And we found the mass of the white dwarf 0.8 solar mass. So we use two machine learning for Cataclysmic Variables Stars. In this case, we use all data of S plus data release 5 and use the Disney. The Disney is unsupervised machine learning for reduction the dimensional reduction. And here we have the partial results for the Cataclysmic variables. Okay, the Disney parameters. In this box, we have on zoom. In this box, we have the point of the Cataclysmic variable found in the literature, in the Cataclysmic variable found in this work through the V shape. We haven't been using in previous work this methodology for segregated objects in S plus. For example, white dwarf and other systems. And now, here in La Plata, with Analia and with Rodrigo, we are working in the application of the machine learning for found Cataclysmic variable and separate between subtypes. Okay? So the idea is use the S plus data release 6 for apply the Disney and found candidate CVs, and before this found the subtype of CVs with machine learning, supervision machine learning. Imagines and gracias.